theorem is called superposition theorem. So what we do in this superposition theorem, let's go through the definition first. A linear resistive network containing two or more voltage sources through any element, resistive or source, may be determined by adding together algebraically the currents produced by each source acting alone. When all the other voltage sources are replaced by their internal resistance, if any, if the voltage source has no internal resistance, then the terminals to which it was connected are joined together, or you can say it is short circuited. If there are terminals to which they are connected and the terminals to which they are connected are left open. Okay, so in simple language, you can say that this is applicable to the circuits in which there are two or more voltage sources, or you can say energy sources are there. So it can be voltage source or the current source, and we calculate the current flowing through the resistances by taking one energy source at a time. Okay, and short circuiting the other voltage sources and open circuiting the current sources. And after we have obtained the current which is flowing through the resistances by other methods, or by taking all the energy sources, taking one at a time, then what we do, we add them algebraically. Okay, so this word algebraically is very important because it suggests that the current which is to be added, it is to be done using vector addition and not simple addition. Okay, this thing is very important. Okay, so this theorem is clear to you. So let's move to numericals. Is this clear to you, everyone? Okay, so focus on the circuit. So this is the circuit where we have to apply the superposition theorem. So what we will do and which sort of problems do we face are we are required to answer. First type of problems can be to calculate the current which is flowing through any resistance. Okay, by and large, in all the theorems which we have studied so far, we were required to calculate the current flowing through the circuit. And once we know the current which is flowing through the circuit, then we can determine the drops and also the power consumed by the circuit. Okay, and as in the case of Thevenin theorem and as in the case of the Norton's theorem, here also we may be asked to verify the superposition theorem. Okay, So whenever we are asked to verify the superposition theorem, then we have to calculate the current flowing through the resistances, each resistances or each passive element using superposition theorem, and also by any other method. Okay, whichever you deem to be, which you find easy. Okay, so simplest one is to calculate using KCL and KVL. But if you find any other theorem which is more useful and easy, you can apply that as well. Okay, so this is the theorem. This is circuit on which the superposition theorem is to be applied. So first of all, we will apply the KVL KCL to determine what is the current which is flowing in this circuit. So these two battery sources are 20 volts and 10 volts, and current I1 is flowing, and in the as the node is appearing, so this current is divided into I2 and I3. So we can obtain the first equation as I1 equal to I2 plus I3 using KCL, and two equations can be calculated using the application of KVL in these loops. Okay, so if we consider the first loop, it is to, you can see the equations given. Okay, you are looking at it, circuits as well as their equations. Okay, so 2I1 plus 4I3. So you can see here, this equation is derived from this. We are calculating using KVL, KCL, or maximum Maxwell's circulating current theorem. So 2I1 plus 4I3 is equal to 20 volts. Okay. Similarly, in the second equation, second loop, you can take any polarity, that is up to you. But if you are taking the polarity based on the positive terminal of the battery, then this will be the direction. So since the current is flowing here and we have taken anti-clockwise, so minus 2I2 plus 4I3 is equal to 10 volts. So we are having three equations and three unknowns, and we will get the I1, I2, I3. Okay. So now what we will do, we will calculate the I1, I2, I3 using superposition theorem and verify that whether these values are same or not. Okay. So we are having two voltage sources. So we will take one voltage source at a time, and the current is calculated, and after the current is calculated for both these circuits, we will add them algebraically. Okay, so considering the 20 volts battery first, and we will short the other source. So now these 2 ohms and 4 ohms are in parallel, and it is in the series combination with this 2 ohm. So the full resistance of this circuit is calculated as this 10 by 3. So voltage is given, resistance is known to us. So the total current can be calculated by applying Ohm's law. So this I1 current comes out to be 6 amperes. Okay. So now you can apply the current division formula to know the magnitude of the current which is flowing through 2 ohm and 4 ohm resistances. Okay, so this formula was already derived, so we can calculate this I2 and I3. I3 is, it can be calculated simply by applying KCL also, because here also this I1 dash at this node, this I1 dash is equal to this I2 dash plus I3 dash. So if one of them is calculated, you can already always calculate 6 minus 4x. So same strategy will be applied to the other voltage source. Now this resistance, other voltage source will be short circuited and the current flow can be determined. So here the again, now these two resistances will be in parallel because now current is flowing in this direction, and this 2 ohm resistance will be in series, so that we get this as effective resistance. Now this is the I2 dash is the effective current in this circuit. Okay, so and rest of the currents I3 dash and I3 double dash and I1 double dash can be calculated using the current division formula. Okay, so if one current is calculated, then KCL can be applied, because we can see that I2 double dash is equal to I1 double dash plus I3 double dash. So if one of the current 1 ampere is calculated, then other is 2 ampere. Okay, so now what we have done, we have calculated the current, the magnitude and the direction of the current flowing through the circuit when the voltage sources are taken one at a time. Okay, now the next part is that we are required to add them algebraically. Okay, so here we have to be cautious with respect to the direction of the current. So here I1 current was from LHS to RHS and its magnitude was 6 ampere. So we have written here 6 ampere. And here the I1 current in the second circuit was from RHS to LHS 2 ampere. So the vector addition becomes 6 minus 2 4. Okay, similarly I2 current is from LHS to RHS as 4 amperes, and RHS to LHS is 3 amperes, so net current is 3 ampere. And in case of I3 dash, in both the circuits, it is moving down. So this 2 ampere and this 1 ampere is added to get the result. Okay. So we have calculated the magnitudes and the direction of the current using superposition theorem as well as using KVL. So if now we compare these two results, we find that these results are same. Okay, so we can say that the superposition theorem is verified. So is this clear to everyone?
Yes, sir.